Welcome to IEEE Project 2013 development. The project title is Lineage Encoding and Efficient Wireless XML Streaming Supporting Twig Categories. This project developed by Star Technologies and implemented core technologies in Java. This paper under the domain of data engineering, that means data mining. This paper proposed concept is main proposed concept is an efficient wireless XML streaming. Here used the twig categories and here is the twig categories to get the output for efficient and energy and latency for the wireless streaming level optimization. Here using the G-node dataset. That means here using the network data set, that file format is XML based format to implement the lineage encoding. So here lineage encoding predicates and tweet pattern queries over the streams. Streaming is a flow of the data. So here using the lineage go to convert the graph based, that means tweak pattern queries based query processing for the mobile clients. So here using the synthetic data set, synthetic data set for the XML broadcasting data set to find on efficient wireless XML streaming and latency also here calculate the calculating. So in this paper, using the main index terms of tweak pattern matching and wireless broadcast and external streaming also. Look at this figure. This is our architecture for the wireless XML broadcasting system. In this architecture here, this is the server side. Server side, it contains a XML repository. That is XML repository. It contains XML data. In our input file is like that sample XML document. This is contains root node for the material and country ID and name, person ID and city and provision also. So this is our sample XML document for the our input format. Um, this file contains the XML data. XML reporter convert to the XML parsing. That means XML parsing means here get the output for the get the value for the country ID and the name and the functions also. Next is streams and stream generation. That means XML parsing data ready to transmit to the client. That is a streaming means flow of the data. So flow of the data, that is streaming data generation to broadcast, ready to broadcasting to the client. Next process is the stream data broadcast to the uh, client nodes through wireless networks. So here calculate the tuning time and access time. In a client side, client will be pass the query request to the server. Server accept the query to return to the service through client. Here broadcast channel receive the selective tuning for the query processing output. So here in our architecture, two level partition process is done. One is the tuning partition, another one is a script partition. Tuning partition means here your XPath query will be tuned, and script partition is the root and some other unwanted element to skip to the skipping partitions. That means for example, this is our query. That means Q1. This is a XPath query. Country and name. Name is a Belgium and France and city. This is our query. This query pass into the client. So this XML XPath query tune partition. That is a mobile client tunes broadcast channel to partition the query. So next is script partition. So country is the main root. That means parent root. So country. Next query is name is the attribute. So next level see the query for the query processing code to country. This is our country ID and the name is Belgium. So refer to the Belgium. And another one is prevention to the parent child of the country. So prevention ID. And the next query is the city. So next visit the city. City is the here will display the months and Charlies and Liges. These are the cities. So training partition to travel the visit the query from each elements. That's a that's a process for the tuning partitions and script partition. Here look here, material is the parent node, parent element, that means ancestor element, and the country is a parent element, and another one is prevention is a child of the country, and the city also child of the country. Either remaining nodes are skipped, that is the skipped partitions. This is the process for the query processing. Look here, clearly your paper clearly told that your paper in a twig pattern queries. Twig pattern queries consist of two or more path expressions. That is comparison between the two or more queries. Here using the one query is a Q1 is a single query, another one is a Q2 queries. Like that, look here. Q2 is a query to visit the here XPath expression country and name to text visit the city, and Q3 is middle level cities, that is located based cities, that is tweak pattern query for the two or more for the expressions involved to satisfy the complex pattern of the tree structural XML data. That is process for the tweak pattern queries. Gnode here get from the global data. That means global data means external streaming data. You can get from you can download some data set from online to get implemented lineage encoding. So here using here using wireless extreme generation algorithm, that is using for the Gnode. That means here using two mainly focus on queue and stock load data structure algorithm to implement to the XML tree. Um, in wireless streaming generation algorithm, here using two data structure algorithm. One is a queue, another one is stock based. Mainly here using this algorithm focus on the AVL tree. That means tree bases node traveling. So that is a AVL tree used for the used to get the tag name to drawing the tree structure with. That is a node depth first search, breadth first search. The visiting the node from graph level stretches. Like that here using the wireless XML streaming algorithm. This is our visiting node, like that G node country and G node prevention, G node city, traveling from that node for the based on the AVL tree format. Okay, so bitwise string and all storage also. This is our main paper. Finally, in our paper, measurement for the tuning time and how many queries passing through our application, get the tuning time and show the result from the graph view. So here using the Q1, Q2, Q3 is up to Q6 level of queries will be tested in our application, get from the tuning time and show the final result in our graph. Finally, in our conclusion, evaluate and perform our experiment to get the efficient tuning time for our each queries. That is, here using the XML for the expression to pass the queries and implement to do the process for the tweak pattern queries and lineage encoding to get the efficient pattern matching. This is our conclusion. Next, we can go to see about how to run our